Here we have the normal distribution finding a raw score. So suppose that the heights of adult women in the United States are normally distributed with a mean of 64.5 and a standard deviation of 2.2 inches. Jennifer is taller than 85% of the population of U.S. women. How tall is Jennifer? All right, so this is dealing with the normal distribution curve. So we have a normal distribution curve that looks like this. We have a mean of 64.5 and a standard deviation of 2.2. So in a normal distribution curve, one of the properties that we get is that the mean and the median are the same. So the mean goes in the middle of the distribution at 64.5. The way we figure out the other points of this curve is we actually add the standard deviation as we go to the right and subtract it as we go to the left. So if we add it as we go to the right, add 2.2 to this, and we get 66.7. Add 2 more, 68.9. Add 2 more, 72.2, 71.1. Here we subtract 2.2. So we add as we go to the right, we subtract as we go to the left, because you want the mean, the numbers are going to get bigger as you go to the right and smaller as you go to the left. So subtract 2.2 would be 62.3. Subtract 2.2 would be 60.1. Subtract 2.2 would be 57.9. Okay, so again, this is a mean of 64.5 and a standard deviation of 2.2. And this is our normal distribution curve. Okay, so this is kind of the way it's set up. And what we can look at this is we can get different percentages. So you've looked at this and then you've done the empirical rule by now. So you know that 68% of the women in the entire population of the U.S. have a height between 62.3 and 66.7. What this problem is asking is 85%. It says Jennifer is taller than 85%. So we want to actually know, and I'm going to draw another curve so we don't mess up this one. We want to know what height over here allows Jennifer to be taller than 85%. So what if this area under this curve is 85%, what height does that actually equal? Okay, so this is what we are going to try to find. So we are going to need to use our z-score. So remember from previous lessons that the z-score is how many standard deviations you are away from the mean. How many standard deviations away from mean. Okay, so like right here, your z-score is 0 because you are 0 standard deviations away from the mean. Here we added it once, then we added it again, then we added it again. So again, these are my z-scores. Here we subtracted it once, we subtracted it again, and then we did it again. So those are my z-scores. So what we need to do is figure out what z-score goes along with 85%, and then we can plant that z-score on our chart to figure out what the height of Jennifer would be. So the formula that we are going to use, you have seen this formula before. Z equals x minus the mean divided by the standard deviation. So here, x is the height that we're looking for. Okay, so x is the data value is what they call it. So that is actually what we are looking for. So we are trying to find x. Since we are looking for x, we actually can go ahead and just rearrange this formula by solving for x. We can multiply by our standard deviation. Our standard deviation cancels out, so we have the standard deviation times z equals x minus the mean. Now to get x by itself, we just add the mean over. That cancels out. Now we have x equals the mean plus the standard deviation times z. So if we use this formula, we should be able to get our answer. Okay. So now let's jump back over and figure out what our z is at 0.085. Use this z button right here. But remember, we are trying to find the 0.85. What number gives us the 0.85 here? So our calculator actually gives us the area to the right here. Okay, so you have two options. You can do 1 minus 0.85 and get 0.15. So you could do z of 0.15 to figure out what number is here. So that would tell us how much is to the right, because this would be 0.15 over here, and that would tell us what z number goes right here. All right, so let's go do that. So I'm going to do z 0.15 and get my z-score that goes along with that. So now we go back to that formula of x equals the mean plus the standard deviation times z. So this is my z-score that goes along with 0.85. So I do that times my standard deviation, press enter, and then plus my mean, 64.5. And this would be the height that Jennifer would be to be taller than 85% of the U.S. population of women.